So we're just going to take a classic example, y equals 1 over x, and we're going to just plug in some values and see what happens. So if I plug in a 1, for x is 1, I get 1 over 1 is 1, 1 over 2 is a half, 1 over 3 is a third, 1 over 4 is a fourth, 1 over 5 is a fifth, 1 over 6, 1 over 7, 1 over 8, 1 over 9. I'm getting smaller and smaller and smaller so that eventually I never hit 0, because no matter what I do when I divide 1 by something, it's not going to equal 0, but I get pretty darn close to it, right? 1 over 100, 1 over 1,000, I get close to it. And that's what we call a horizontal asymptote, when it levels out. So your graph, that's what it's doing when x gets big, when x goes to infinity. When x is like a really big positive number, your horizontal asymptote ends up being y equals 0 in this particular case, as that's what it levels off to. So you guys are familiar with this graph. It looks kind of like that. And on the other side, when x gets big in the negative direction, when x goes to negative infinity, you have the same thing happening. You have, when I plug in negative 1 for the x, I'll get negative 1, sorry, 1 over negative 1 is negative 1, 1 over negative 2 is negative a half. If I plug in negative 3, I'll get negative a third, negative a fourth, negative a fifth, negative a sixth, negative a seventh, negative an eighth. And so it just gets tinier and tinier and tinier and approaches 0. And so it doesn't matter what it's doing anywhere else. In fact, it could even cross it in between. You can cross a horizontal asymptote. In this case, in this particular case, you don't. But all the horizontal asymptote is asking is what happens when x gets big. So you can cross it as many times as you want, but when x gets big, what's happening? And so in this case, we can see y is 0. And so I gave you the rules that if it's got a bigger bottom, you want to compare the highest power of the top and the bottom. So the x was to the first and there were no x's on top, so this was the case where the power on the bottom was bigger, so it ended up going to 0. And if they were the same, you could take the coefficients, and if it's top heavy, there's no horizontal. But we kind of want to explore that a little bit more. It wasn't too hard to use, but what's going on here? So this was a nice case. I could graph it pretty nicely. And then if I have other cases, like this one here, you're looking and you're like, okay, well, I want to know what happens when x gets really big. Well, when x gets big, this bottom gets ginormous, right? It's like 3 times 100 plus 45, or 3 times 1,000, or 3 times 1,000,000,000 plus 45 is a really, really big number. And if I have even 12 pieces of pizza and I divide that amongst 1,000,000,000 friends, I don't get much pizza. So sad. So sad. This is going to go to 0. It's like 12 divided by 1,000,000,000. 12 billionths is basically 0. So that's why if the power on the bottom is bigger, it's going to go to 0. Now, even in this case, right, you compare the highest degree of the top, which is 4, and the highest power on the bottom, which is 5. So even though you're adding all this stuff to the top, when x gets huge, this stuff is insignificant, all right? I mean, you can kind of see that the 2's not going to make a big deal, like just adding 2, but all this stuff ends up not mattering. This guy wins. The biggest power is controlling what happens. And this is the idea of a limit, which you'll get to in calculus. So you're bordering on it here. I mean, this is the idea. So so the biggest power is controlling it, and the bottom is bigger. This x to the 5th is going to get big, be so much bigger than 7x to the 4th when x gets big. He wins. Bigger bottom. It's just going to go to 0. This guy is going to bring him down to 0. So it's a big number divided by a really, really even bigger number is 0. Okay. All right. So next case is when the degree of the top and the bottom match. Like this is an x to the 1st and this is an x to the 1st. So when x gets big, this 45 is insignificant next to the bigness of this, right? Even if this were 45,000, this 3x wins. When x is infinity, when x is huge, it's controlling what's happening on the bottom. So if the 45 doesn't matter, I'm going to block them out, and then it's going to be 12x over 3x, so those x's are going to cancel, right? And then you're looking at 12 over 3. So you're going to have a horizontal asymptote of y equals 4. So you're basically saying that y is approximately 4 when x gets really, really big. That's what we're doing. This guy here, again, they match, so this 4 is insignificant next to the biggest power, and so that guy basically goes away, and you're looking at x squared over x squared. Well, that's just 1. So y is essentially equaling 1 when x gets big. Last case, when the top is bigger than the bottom, this is so much bigger than that, it's not going to settle. This is going to get huge. No matter what we try to divide by, it's not going to bring this down. So it's going to go to infinity. It's not going to level off, so there's going to be no horizontal asymptote in these cases. And you're going to have slant asymptotes instead. And we can see what it's going to be by doing a long division. So if I have x squared plus 2x, and I divide it by x minus 1, in this case I could have done a synthetic, but I'll just do it this way for the more general case. So I do my long division, x goes into x squared, x times x minus 1 is x squared minus x. I subtract, x squared minus x squared goes away, 2x minus a minus x is 3x. And now I do it again, x goes into 3x 3 times that is 3x minus 3. I subtract, those go away like we planned, this will be a 3. So I have a remainder of 3 over x minus 1. Now what we've done is my y equaled this over that, right? So my y was this divided by that, which I've proven equals this, right? So this is y. Y equals x plus 3 over x minus 1. This is another way of saying that, right? I just divided it. So hey, okay, if my goal is to say what's happening when x gets really, really, really big, well, when x gets big, this thing is going to go to 0 for the same reasons we talked about before. This bottom is huge, so 3 over a huge number is going to go to 0. And so basically when x gets big, the y is going to be equal to this. So you can ditch the remainder, and your slant asymptote will be y equals x plus 3. So when you go to graph it, you're going to have a line and some sort of vertical, so it's going to approach this line when x gets big. So it's going to get close, and so if you looked out way and out, essentially it would look like a line the further out x as you looked. Oh, having trouble speaking now. But we'll do more examples of actually graphing them later, but I just wanted to get through the idea of finding the asymptotes. So hopefully that made some sense. Thanks.